The closed interval test is also called the candidate's test, and it allows us to find the absolute extrema of a function on a closed interval, meaning we can find the absolute maximum value or the absolute minimum value on the closed interval. We need two things to happen. We need first the function to be defined on the closed interval from a to b, and second, we need the function to be continuous on the closed interval from a to b. I had to write that in there. I almost forgot that. But it's really important because you can't have the function have a whole or even a vertical asymptote on that closed interval, because then it'd be extremely difficult to find the absolute maximum value on that closed interval. Next, we need to find the critical values on that closed interval, and that is the location C where f prime of C is equal to 0, where the first derivative equals 0, and that allows us to find the local maximum and the local minimum values. So the candidates test, the closed interval test, we need to check the y values of each critical value. We find f of c for any critical value c, and compare it to the y values of the endpoints, f of a and f of b. And you need to check the endpoints, f of a and f of b, because you won't have a local maximum or minimum value on the endpoint, but you might have an absolute maximum or minimum y value on an endpoint. This might make more sense if we take a look at an example. Here we have a function defined on the closed interval from -2 to 5, and the function is a polynomial function. Notice that because polynomial functions are continuous over all real numbers, so the function must be continuous on that closed interval. Hence, we could do the closed interval test, the candidate's test. We start that out by finding the first derivative, f prime of x, which is equal to 6x squared minus 6x minus 12, setting the first derivative equal to 0. You might want to solve this by dividing the entire equation on each side by 6 to simplify it. 0 equals x squared minus x minus 2. Factor this equation. X minus 2 times x plus 1. Set each factor equal to 0. Isolate the x, and you'll get the x value of 2 or negative 1. These are your critical values, and you might have a local maximum and a local minimum on either of these two values, so we need to test these values. Here comes the closed interval test. What you do for the closed interval test is organize a table of x and y, or output f of x values, and you always put your candidates for the critical values in for your x values. You must test 2 and negative 1 for comparison. Next, you have to test the x values on the endpoints. You must plug in the -2 and the 5, and we need to compare these y values. I recommend at this point pausing the video when you're ready, and you're going to plug each of those x values into the function, find the y values, and we'll check in. So whenever you're ready, go ahead and resume the video, and let's compare. Did you find f of 2 equals -19, f of -1, which is 8, f of -2, which is -3, and f of 5, which is 116, a very large positive number. So compare those y values, and what we need to look for here is the absolute maximum y value, which is 116. So we can write that as f of 5, which is 116, but take note that the 116 is the absolute maximum value, because the absolute maximum value is always your y value. But it's nice to write the f of 5, or say at the location when x is 5, because you might need that information later on down the road. Then compare your y values from your candidates and find the absolute minimum y value. The absolute minimum y value is -19, but you could write this as f of 2, which equals -19, where that -19 is that absolute minimum value. Now, this is a really nice candidates test to be able to perform, because you don't need to know what the function looks like. You don't need to know all of the behavior of the function. All you need to do is check the important values and compare them for the absolute minimum. Let's take a look at what the graph would show us here for comparison. Here's a graph of the function, but you must remember that we're checking only on the closed interval from the x value of -2 on out to the x value of 5. Now that one doesn't show on the page, it's way above there, but it is very clear to see that the 116 is the absolute maximum y value. As shown on the graph, it reaches the highest point, and the absolute minimum y value is that -19, because that y value went lower than the y value of the endpoint when f of -2 equals -3.